So it's in the chapter 4 of our textbook and Appendix C. And it's kind of confusing on how they kind of explain corporate data modeling. But to quickly explain that, it's basically getting the business requirements and making sure that you're able to diagram that, okay? And I suggest everyone to please close your laptop for now, because I really want to maximize interactions with you guys. So close all your laptops, focus on me. Again, you guys are paying for me to talk, so please let's maximize that. Again, corporate data model, it says in the textbook, when you say corporate, it's just basically the entire enterprise, entire organization, the entire business. And then, so now you're asking, what's corporate data then? So it's basically what the data is being used by the enterprise or the company. And it provides data requirements for the whole business. So you don't just go grab random data that's not relevant to you, as we talked about many times already throughout the 2 weeks. And before even this one, going back, so now you have to figure out. So let's say your business is more focused on driving sales. So you should get more data for sales. If your data is more like recruiting, you should get more for HR type of data, right? And so now you have to prioritize, because you can't just grab all data and analyze it. You also have resource constraint all the time, okay? So with the corporate data model, it now goes down to what we now been discussing as well in databases, that you would have entity attribute relationships. So basically, entity is just an object, a thing, a person, and it's in the interest of the business. That's what they want. That's the data that they need. They need a person object, or let's say they need a registration object, they need a booking object, or entity, okay? So those are the tables. Entities are the table's name. Next is the attributes. What are the properties or definition? Do you need the age, height, feet size? Oh, does the registration need to have a start date, end date, number of people coming, who's the one teaching, if it's a training event? Relationships are basically associations. I know this may sound confusing, but basically in English, when you drop this one, when you say relation, that's the same meaning as association. So when you say relationship, I have a girlfriend, our relationship, it's talking about the relationship itself. But when I say, what's our association or what's our relation? Think about something that's in the document. We're just friends. We're nothing. I'm single, she's single. But if we're married, I can say, oh, our relationship, we're partners, but like our association, we're married. So association talks more about how. How are you related? That's now we go to the, oh, this table and another table's relationship, what's their association? One to many, right? Many to many. One and only one. So we'll go deeper with this one. Again, corporate data model helps create the database design model. And to build your corporate data model, first we talk about top-down. It just means that focus first on the big picture before becoming very specific. So another way to think about the top-down approach, it comes from the manager and then employee. That's a top-down. If it's a bottom-up approach, it's from the view of employee, then going up. So meaning, why can't we be specific? Because again, if you become specific enough, oh, I need a pen, and then you just grab a pen, and then now you acquired it. What if, and then you ordered 10,000 pens. What if next time you said, oh, we're not using pens anymore, we're gonna just put it in digital. Now you bought a lot of pens as well. So careful of that mistake. And then focus on the core business, which I talked about earlier. If, let's say you're dealing more of like security, so you need to go for security data, not more of like the whatever other data that you need, right? Whole enterprise is the scope. Again, general overview. future-proof, which he shared to us. You must make sure that your model is future-proof. But then again, not all organizations could do this, and a lot of people either failed or incurred a lot of what they call technical debt, meaning they built something and now they are in the future, and now they have to fix a lot of their data modelings in their database, and that costs a lot of money. Same goes with software development. If you start building something with an architecture that's so rigid and not flexible, now once you want to try to change something, even one, it would cost you a lot of money or time, just because the developer would look at like tons and tons of code just to fix something. Okay? Cooperatively develop means make everyone involved, make sure that they require that data as well, right? And make sure it's relevant to other department as well, because it may happen that one department and other department are just getting their own data, but it was the same data. Why not just share them, right? Consensus, not perfection. As he shared a while ago as well, even though we want to achieve future-proof, if we plan so much, we might not end up not implementing anything at all. So achieving a consensus meaning, oh, did you agree? Do you agree? Do you agree? Okay, most agree, let's implement it, right? If it's not perfect, but let's implement it. Okay, now this example in the textbook, it's kind of hard to understand. I look at this many times as well, but my clue is, because I used to play a lot of Command and Conquer Red Alert, so this kind of gives me a clue, oh, depot, and then I start Google searching. So most of the time you hear depot when it's used in the military. So basically a depot is something where you put all of your equipment, supplies for military use. Hence, it's a supply chain model. You supply, right? So this one only says that in a depot, there's a smaller sub-depot, okay? And inside that sub-depot, there's a supply unit. You can think about the persons, there's a supply unit, and also in the supply unit, there's a unit. So right now, you could see the relationship. I'll explain more of these notations later, but I can explain now that this one depot has many, one or many. This crow's feet, it's one or many sub-depot. A sub-depot can have one or many supply unit, and so on. Now, it says in the textbook as well, it's unstable. The problem with this is, let's say we remove this sub-depot already. We have a depot, we said, okay, this doesn't make sense, no more sub-depots and depots. We still have supply unit and unit. It looks easy when you just demolish a building, but if you have a database that's framed in that sense, you have to make a lot of changes. Because now you have some data here that are dependent. And you have to make sure that once you destroy this, it doesn't affect the others. Okay? So in the textbooks as well, they say, let's improve it. So why not have a unit, right? And put two of them inside. So the supply unit is still being supported by unit. It's still the same. Supply unit has a one-to-many relationship to the unit and other units. Okay? But the problem is with this one, they're still together, right? As with this one as well. What if I have other supply unit, medical unit? Oh, let's create two. Now you're duplicating, right? Still, this one, they combined it. And now, instead of decoupling, separating, it's already integrating again, unnecessary integration. Because what if I want to change something here with medical unit or the unit, right? Now it will affect everything. So this is what we want to do, generic unit model. This now is kind of similar of what we're doing with the ER diagrams. This is a separate table, this is a separate table, this is a separate table, this is a separate table. And now we try to define this. I'll give more examples, but right now, the way you see this is a unit type has one to many units, okay? A unit type is described by a unit. A unit is a description of unit type. We'll try to skip this just because there are better examples. But before that, this is another part of the textbook where we're talking about the top-down approach, right? This is the entity thing. any one of you have programmed before, you know object-oriented programming, basically the same thing. You wouldn't want to create something that's very specific. Let's say you created a vehicle, right? And then now you want to change materials. Now you keep having to build other stuff instead of like having a materials class, just saying, okay, it gives me iron or wheels or whatever. So things like this. So we want to inherit properties instead. Okay? And just talking about inheritance quickly, like there could be some problems. For example, I create a dog, and a dog can pee, or bark. I create a robot that can fly. And what else can a robot do? I forgot. What? Calculation, sure, okay. What if I created that data model? I did not think in the future. And I need to build a robot dog, right? In terms of the database design or programming design, it's going to be hard because now you're going to inherit two. When you inherit from the dog, so the robot dog can bark and pee?
No.
He can pee, right? But he will inherit that data, that property, I mean, that attribute. Same goes with calculations and flying. It will be inherited with the robot dog, which is fine. I know, actually, because the robot dog does not fly. So now, make sure that you create your model future-proof, think ahead, right? Another example is, before you're thinking about, oh, let's create a backpack object. And now the backpack has a lot of stuff, right? How about saying a four-wheel object? Now you can make a luggage with four wheels or a car with four wheels from that one generic object. Okay? So this graph just shows that if you build something wrong, not future-proof, and now you would incur a lot of high maintenance costs, hardware costs, development costs. That's why I'm talking about programmers trying to fix it. Takes a lot of time. There's a problem. They don't know who to blame. They don't know which software development team. Like just a while ago, on my way to Bellevue downtown, I was talking to my friend. We're doing carpool, and he's like, you know, we have this monolith architecture, meaning a rigid and just everything was just in one place. That's what you call monolith. And saying, you know, it's so hard because like the other developers, we don't know who's really to blame. They did something and now it's broken, and there's so much to look at instead of like decoupling them in different software or different stacks instead. Again, generic is way better than being very specific. So now we'll go on to the ER diagram. With this example, I hope this can clear up how we use the notations as well. So before this one, let's discuss this one first. Okay, let's discuss this one. If you see the crow's feet, it always means many. But if you see a circular, it means zero. And you can say, this relationship has zero or more. And this one, crow's feet, again, it's many. And you see this one line is just one. This means one and only one. It means you can't have two. You can't have more. You can't have zero as well. One or zero. This is an or, not an and. Everything is an or except for this one. So let's go back to that ER diagram to explain. So if I want to start with the doctor interacts with the patient, right? So now, what's their association or what's their relation? As the doctor, it's going this way. Don't look at this way first. Just look at this way because it's going there. A doctor can have zero or many patients. As a doctor, I go to my work. It may happen that I don't receive any patients today, or I may receive one or a lot. Going back, so what's the patient's relation to the doctor then? when I, as a patient, go to the hospital, I usually just go look one and only one doctor. I don't go to a doctor's appointment without receiving any doctor at all, right? That's so weird. I have a doctor's appointment, and then a nurse comes in, and then no doctor. So you should have one and only one. Now, let's say you come in as a patient, you need a room, right? So,
wait, Sam.
go ahead.
I think in general, a patient can have many doctors. Like a surgeon or they have a meeting. A one-time visit.
Yeah, so that's good that you mentioned that, and that's good that you mentioned that as well. Because in every scenario we have, in whatever aspect, we always have assumptions. For here, our assumption is it's a doctor's appointment. That could work as well. Let's say you're going to be passed down because you have to go for general practitioner, then go to surgeon, but this now holds true. This means that one doctor can have multiple patients, and we can assume that this is a doctor's appointment, and a patient can have one and only doctor. Okay? In that scope as well, we can say that what's the relationship of a patient and a room? Okay? So look at this first. So a patient can have only one or zero, right? A patient can go in the hospital, maybe he has an appointment, doesn't need a room, or needs one room. He can never or should not occupy 2 rooms at one time. It's weird. It costs twice the money. At the same time, what's the relationship of room to patient? Well, a room could have 0 or many patients. There are other rooms that, let's say, either for experimental procedure, or let's say they have I don't know here in US, but in the Philippines, we have a shared room space. If you don't have much money, you can definitely still stay in the hospital. Let's say you need to stay in the hospital and you share it with another patient. Okay? So now, let's talk about room and nurse then. So for a nurse, for a room first, room to nurse, a room can only have one or many nurses, right? Because we can assume that it has to attend to a patient. And then again, now this makes sense because usually there's different nurses that comes into the room. And let me see if that was correct. And nurse can be relationship to room, one and only one room. Oh, I made a mistake. So going back, I think this is the one. The assumption is for a nurse, the room will be staffed by one and only one nurse. Okay, let's correct that. The other way around, a room, multiple rooms can have nurses each. May sound confusing. Always try to shift your perspective. Like example, this one. One doctor, how many patients? One patient, how many doctors? Okay. And this one as well, let's say prescription. A prescription can contain one and only drug. True or false? A drug can have one to many prescriptions. Meaning, let's say someone prescribed a drug for headache, right? I can have prescription for you, prescription for you, prescription for you, and they all have the same drug. That's what this means. A headache drug could be prescribed many times. Okay? And then a doctor can prescribe to you one or many prescriptions. Okay? But usually, we assume that in a prescription, it only shows one drug. And I'll create you another prescription for another drug. Okay? Again, this model may or may not work depending on how the hospital rules, right? Or the healthcare regulation. We should have started with this so simple. Okay, so again, let's start with the top. A student can only have one and only seat. I can sit here, right? We cannot have 2 people sitting there, right? It's weird. The seat also can only accommodate one student. Okay, perspective. Perspective of student, I can only sit here. Perspective of the seat, if this has a brain, I can only accommodate one student. Same goes for here. I am an instructor. I can teach multiple courses. Okay? One or multiple. But you can never have an instructor that does not teach anything. Why did you employ him in the first place? Right? At the same time, for the course, let's talk about only one course. This course is only taught by one and only one instructor, which is me. But again, there are exceptions. If I get sick, I can postpone the class or substitute teacher. But you can still argue that, well, he's a substitute teacher, not the instructor. Okay? We'll go next. Student can take one or many courses, but never zero courses, especially for international students like us, right? And also, a course can have one or many students. If, let's say, this course, no one enrolled, this course would not exist. It's canceled. And if you're only one, that can still happen, but you have to pay more to make it, okay? So, this one teaches a section. So a professor could teach zero or many sections. I don't know that part. I forgot what that is. What's a section? I don't know the context. So that's another reason that you have to research more. Like for me, I could have a different interpretation of what a section is right now. Could be a section of the class, section of the chapter. I should have read more, right? And when we put them all together, it makes more sense now, right? Student fills seat, seat fills student, student takes one or many courses, a course can have one or many students, instructor can have one or many courses, a course can have only one and only one instructor, and so forth. Okay? Now, let's talk about primary keys, because we're going to transition to exercises again. So aside from doing the, oh, there's a question, we're also doing something that I'll need your laptops, and you need to build something. Okay? So now, primary keys, basically they're the unique identifier for your table, and this is a MySQL statement. It's a SQL statement. It may be true for some other SQL databases, but it may just differ in some keywords, but still the same structure. Okay? So let's say I create a table persons, okay, that's the entity, and I have attributes. The attributes for a person would be the ID, and then the last name, first name, and age. And the database management system doesn't really know what's their primary key. You have to declare. To declare that, you also put, hey, please use my ID as the primary. Okay? Other keywords that we have here is not null. It means that you really have to put numbers there. If not, you can, when you put the entry, adding a new entry, it will fail. Okay? Last name as well. If you did not put any last name, it will fail. However, in first name and age, you can leave it blank. Because apparently, in my experience as well, we would have people with only last name and not have first name. So how do we make foreign keys then? To recap, a foreign key is basically just a primary key of another table that you want to use in this table. So for example, the persons table, I want to use it in my orders table. It now becomes a foreign key. So to do that, let's create a table first called orders. That's our entity. That's our object. And inside the orders, we have attributes, order ID, the number, person ID, and then now we declare the primary key for that table for order ID. And now we want to reference. So he says like, oh, let's make person ID, which I declared here, to be a foreign key. But now the database doesn't know where is it located. That's why now you use references. You tell the database management system that, hey, it's located in the persons table, and the column name is person's ID. References is for letting the database know where the foreign key is located. Okay. Now we don't want to end up creating the person ID. Oh, enter 1, enter 2, oh, enter 5, enter 6, and then someone comes in you, oh, enter 1, oh, that's the same. So to avoid that, we put this keyword called auto increment. Basically what this does, if, let's say if you guys are signing up to Facebook for the first time, right? You never put your user ID number 1, number 2, because it's already hidden from the user. But whenever I do another entry of the record, it assigns me a number, which you guys won't see. But in the system, this would keep going, oh, first entry is 1, 2, 3, 4, 5, 6, 7, 8, and so forth and so forth. So just this avoids for you manually adding the number and making the mistake as well. And that's auto increment. We'll quickly talk about muddiest point, association versus relationship. Association is synonymous to relation. I know English is kind of janky. I'd rather have Mandarin, it's easier. Relation is, again, how things are connected. Again, association and relations are the same. Okay? How things are connected. However, if you say relationship, it's the state of being connected. What's your relationship? Right? Are you single? Married? Okay? Again, if you go back to databases, when they ask, what's the relationship of customers and orders table, let's say, you would say, oh, the relation is one to many. Okay? Corporate data models suitable for it basically formalizes and represents the things, objects, entities important to an organization as well as the rules governing them. Again, most of the time you won't be the one implementing this data model structure. Usually in an entry level job, you're doing more of the SQL queries. Oh, they need the management needs me to extract data or SQL queries. Don't really change the design. It's usually the senior, the veterans, or the database administrator that fixes this. So you're pretty safe for now. Someone mentioned about databases and scalable data structure. So I'll mention it anyways, because it's also important to people who are doing business, IT, developing, whatever as well. So we'll talk about scaling. So when we say scaling, it's basically, in terms of the resources, you're adding something, right? So when you have a computer, this one, when I say, oh, it's so slow, what if I have more files, pictures, videos, right? What do I do to accommodate those? Oh, I can do vertical scaling. I can add more memory. Your 8 gigabyte RAM becomes 16 gigabyte RAM. Or your hard disk drive becomes 125 gigabyte to 256 gigabyte. So that's vertically scaling. You just have one computer, or they call it server as well, one server, and you just keep adding memory physically. However, this has some limits because your computer or server has physical limitations as well. You've never encountered buying an iPhone, 1 terabyte, no. It's like 156 gigabytes, right? That's their hardware limitation. That's why that has a problem, and one of the solutions, what they call is horizontal scaling. Instead of just having one computer, adding a lot of memory, why not I put something that would distribute the load to this and this. And now they're connected to a network. I basically utilize 2 or a lot of computers or servers. So now you have distribution of resources. Okay? And this goes back to database as well. What I'm saying again, it's a load balancer. Now it separates in different auto-scaling groups. And I'd like you guys to focus here. Let's here first. So let's say you have one database, right? If you only have one database, what if you have millions of users doing this? And that users include your customer and your analyst, meaning you would have someone in your company adding data right into the database, adding data right into the database. You also have a customer looking at products in their e-commerce website, reading the database. The problem with that, this becomes too hot. Everyone wants to access this database, right? Meaning now it's overloaded. What you try to do now is you create a replica or a copy, right? You make copies of this database. And we'll call it master and slave. Why master? Master because that's your primary, okay? These are slaves because they are just a copy. What's good with this kind of structure is if I have a company, I have someone inputting data, I want them to write to the primary database. And the primary database now creates copies. Why? So that I would say, hey, load balancer, if I have a customer looking at products, looking, meaning reading in the database, why not just make them read in the other database, the copy? Now, this becomes not hot, and now the load and resources becomes distributed. Okay? Another, to connect this to SQL queries, I have a company, I have someone inputting data. What are they doing? Insert into blank, values blank, right? That's right into the database. You can also say delete from what column to what column. That's also right into the database. And if you have customers looking at your e-commerce website with products, they're just typing keywords. Again, that gets translated to SQL queries, which is select. Basically, all the select statements are doing the read in the database. Okay? Let's see. So we'll have SQL exercises before we take a break. Do we have more time? Okay, maybe let's take a 10-minute break and please come quickly. Because then again, Eugenio, you were not here. I told them that the last hour, we would use that to go to the invited talk so that you guys get to meet people and invited speaker. And that's why the second half, we'll do just a glimpse. We'll do this. Aside from that, we'll do something new as well. I'll give you the output. I want everyone in their computer to do this. Create this database, build the table, insert data, update data, recreate table, insert data, update data, on update cascade, delete data, on delete cascade. It shouldn't be too hard. I already added some syntax here. That's a big clue, and this is a big clue. Okay? So please, 10-minute break. I want you back 1:57 so we can do SQL exercises. Okay. Everyone, we'll be starting with our SQL exercises. At first, I'll show you 4 questions. I think it's only 4. 4 things that we need to know is where, and using the in, the and, the like, case when, then, else, and then. So where clause is basically when you want to limit your search. Let's say select first name from, let's say, instructor where equals Clark, quotations Clark. Let's say we're in clause, and then the in so in basically allows you to do multiple values. So let's say where select first name from instructor where last name is NGO, comma, and then let's say another chung. So basically, I'll get me and another professor. So the in clause, the keyword, lets you have multiple values. Okay? And then and is basically restricting, meaning I want someone whose first name is Clark and last name is NGO. Okay? If I don't see, let's say if I have an instructor, his name is Jason, then NGO, I wouldn't see that because of the N. The like operator is basically a pattern matching. You would use this one and add a string. Let's say like ARK. So everyone with the pattern that has ARK, like Clark, Shark, Mark, I would get that as well, the data. The case when, then, else, and as, basically very long, but if you've done basic programming, that's just basically an if and else statement. So for this activity, I hope we can just spend 20 minutes for the exercises. I'd like you guys to group yourself quickly now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So one group of 3, and the rest is for 2 people. I'd like you to mix, and if you think that you're still kind of weak in SQL queries, please pair up with someone you think that is good so that you learn. Okay? Do it now. Stand up. Find a partner. Not from the same table, hopefully. Okay? Grab your pens. 3, 2, 2, 2, 2. I'll make it easier. 1, 2, 3, 1, 2, 3. 3, 3, and 3. 3, 3, 3. Okay. 3, 3, 3. Okay. Sure. So first question is this one. How can you produce a list of facilities that charge a fee to members? And this is the expected result. You can also try to Google what you need. I'll give you the clue. I'm not going to show it, but I'll tell you the clue. What you need is basically you need the where clause, only the where clause. Select from where, and you'll find out the answer. So write the answer on the board. I think this is a learning lesson for everyone. For first exercise is basically the first clue, vague. Okay, I tried to see, okay, everyone's still lost. The second clue is clear, but when I got to the third clue, it was super clear already that I say, I want all data that select star, right? I didn't say facilities because it already says there. So that's already next clue. And then I say, where member cost is greater than 0. I already mentioned that many times. So listening clearly, you never know that that's the clue already. Because even in interviews, you will encounter some good interviewers that really helps you. But if you're not listening, you don't know what's happening. Okay? Let's move on to the next exercise. Again, this should be so hard. It should not be very, very hard. And big clue. It's very related to the last one. And you need to use an N keyword. Okay? Even though we're talking about SQL, I don't really care much about if you get the syntax correct or wrong. If you put it in another way, but the logic makes sense, I would say, oh, just write this and you're good. So always try to read. Use your elementary mathematics to separate things. make equations. Once you get that, now try to create the SQL statement so that you won't get like, I don't know the syntax. No, check the equation first. How can I do this? Okay. Next question. This one would be, if you were listening in my lecture, the clue is using the where and in. Because it says here, don't use the or operator.
这个你来试试。它已经给你定下了，对吧？
So make your other
这个都是那个表，也可以用 or， 就是学它所有的。想想我们刚才说，这个的话一般都是大写 select from where 那边是。但是你在 SQL 里面，就是在软件里面用小写，它也识别得出来。就刚刚我们跟你说代表 or 的那个 star。
Again, you can quickly look at Google how to use where in.
We should use and, right? Can't?
Nope.
上面是 table 的名字。
Because if you say 1 and 5, you'll not get it.
可以 cd 点 facility， 也可以直接 facility。如果你只有
Yeah, you can Google
CT
where
也可以这样，因为它只有 cd 嘛。
so that you
CD 是
can
这个
write
意
what
思。
your answer. Okay? On the job,
Where?
you will be doing Google first. I'm
它
letting you
有
guys
条件
Google
是分
how to do where
因为有
blank
两个值
in.
嘛，就是刚才我跟你说的用那个 in。
Question again. The clue here, this one is not as complicated as the where. Google like, the like keyword. Produce a list of all facilities. Everyone knows how to do that. Select what? Star. Select star from facilities. Okay, that's good. Now, with the word tennis in the name. A while ago I mentioned what keyword do we use if we want to search for a pattern? That's like, right?
Like.
So you can do a quick Google search. How do you use like? And then you can write out the answers right away.
那我刚才说的那个 like 就是它把所有包含这个 keyword 都放进去。你来写休息。
Here, if you don't have a working system, just look at the other people's computer, or you can use SQL Fido because it's going to be a very small database. If it does not work, if you got stuck on some part, just look to your group mate's computer. Just make sure that one group has at least one working computer. Okay? This time the exercise is we'll build database from scratch, and then we'll insert values. We'll assign primary foreign keys, and we'll also do something like when we delete something, it should delete something as well. For example, if I delete this class, it means all of the enrollees should be removed right away. I don't have to manually delete a class and delete every one of you one by one, right? The class does not exist, instructor and student should not exist right away from the database. Correct? Correct, right? So that's called cascade. But now, I'd like you to build a database called FK demo. It's not the bad word, okay? It's foreign key demo. So every one of you already know how to build database, right? So build this now. Build this first. Come on. You can Google or go to hands-on practice 1. How do you build a database? If you forgot, totally fine. Go Google how to create a database in MySQL. By just 15 seconds, you should get the answer already. If your group is finished, raise your hand so we can proceed. If you're struggling, ask your teammate. If your teammate can answer, it's fine. Ask the other group. Okay, let's proceed. Now, we have the database. Don't forget to use the keyword use, space the database name, which is fktable, semicolon. Now we want to add tables in that database. Let's add the first table. And here's a very big clue. The first is, this is my expected table, meaning if I describe categories, it should look like this. But before that, I should do something like this to create the table. Okay? So this is your clue. Both of these are your clue. This is the command, the syntax that you need to do. This is the expected result. Okay?